what is your thought about the next problem? Group them again. This is about the same thing. We're going to group it again. So if I group the first two, what can I take out? An x squared again? Leaving me with, I'm only grouping the first two, so that's going to leave me with x plus 3. If I take out the x squared. And what about the next two? What can I take out of those? Negative 4. Now remember, you took out a negative 4. So that's going to be a positive x and a positive 3 because you took out the negative.
Don't you want the x plus 3 and x plus 3 to be the same?
They have to be the same. Yep. If you have done it correctly, these will match. Okay? So now I'm going to write down my match, which is x plus 3. And then what else do I have? If I write down the x plus 3, x squared minus 4?
X minus 2.
And that's the difference of squares again. So I have x plus 3, x plus 2, x minus 2. And there's your equation. Okay? I don't know. Frozen.
How did you know that?
Frozen in theology.
All right. Now, where do my dots go? Because we did a lot of work there, but the job is to sketch it. So where do I put my dots on the axis here? Negative 3, negative 2, and 2. Is that okay with everybody? Now, just like the last problem, isn't this a cube? No. So you know what y cubed, or excuse me, x cubed looks like. So you're going to start in the same spot. You're going to start down here, and you're going to come up to that point right there. Now this is just like the last problem because do we have any exponents? So we just go right through, come down. Oops, missed it. That's all there is to it. Why am I going through those dots? Because there's no exponents on any of them. All right, we have one more, just exactly the same kind of problem. So let's see if you can get it factored. See if you can do the grouping and get it factored yourselves. Don't forget, tomorrow is the last day for the canned food drive. No. You're just going to take out a 2x squared. Yeah, don't take out a negative 2 unless there's a negative in front of it. Farrell's absent.
David's at a doctor's
He's at an appointment. He said I got him marking absent, so I don't know where he's at. Katie's. Okay. Hey, Jaden, do you have this thing factored? Put your mask up.
Yeah, it's right.
Let's not be breathing on each other. All right, you have it factored? So you took out a 2x squared, hopefully, I'm looking at the first two terms. And that left you with x minus 1.
Yeah.
And now, see how there's a Ella, see how there's a negative here? So I'm
Yeah,
gonna
that
take out
one
a
is a
negative now. Yeah. And that's gonna leave you with x minus 1. Because if I take out a negative, it makes this term positive and this term negative. So now I have my match, which is x minus 1. And then I have 2x squared minus 8. Now what are you going to do with 2x squared minus 8? You can take out a 2. All you can take out is a 2 there. So I'm not trying to be tricky, but I'm going to put the 2 out in front. So I'm taking a 2 out of this, but I'm writing it out in front of the problem. And that leaves me with x squared minus 4. If I take a 2 out of this. Now what about x squared minus 4? Breaks down to the difference of squares, x plus 2, x minus 2. Now, the 2 out in front, we talked about this. We don't need to pay attention to that unless it's negative. Because negative would turn my picture upside down. But in terms of our sketching, that 2 doesn't matter. The dots come from the parentheses. There is no dot for this. Only the parentheses, only the x things get dots. So we have a dot at 1, a dot at negative 2, and a dot at 2. Caroline?
Is it still gonna be down up?
What?
Is it still gonna be down up?
Well, why would it not be?
If it's negative.
If it, do we have a negative out here in front? No. So if there's no negative out there in front, it behaves just like it always does. So if it's a cube, it starts down here. Now, am I going to be doing any bouncing in this problem?
No.
No, because again, we have no exponents here. So we're going to go just zip through, and there it is. Now I want you to look at the last 3 problems that we've graphed. Don't they look about the same?
Yeah.
Yes, because that's what x cubes look like. That's what x cubes look like. Okay? Now, 2, 3, 2, 4, and 2, 5 really kind of all blend together. And so, I'm going to look. I think we have done enough to do the 2, 3 homework. Yes. Yes, so 2, 3, you can do the 2, 3 homework, and that will be due on Tuesday. Tuesday. All right, so 2, 3 homeworks due Tuesday. Sign out. All right, now. All right, now, okay, so everybody heard me say 2, 3 homeworks due Tuesday. You can do it right now. You have all the skills to do it. Let's look at number 4, because number 4 is different. The directions are exactly the same. But what do you notice that's different about problem number 4? Well, yeah, you see there, some PRR, what the heck's that? But we'll talk about that in a minute. But I want you to think about,
And you can't take anything out of this.
aha.
Bro, can I go tell Mr. Kennedy to turn the camera?
So, I'm not supposed to shut the door, but we'll make an exception. Okay.
I was in high school.
What is the problem here? The problem is grouping isn't going to work. Because while you could take an x squared out of the first two, there is nothing you can take out of the second two except a -1, and the parentheses won't match. Can you see that? And if the parentheses don't match, you can't do it. So this problem does not factor by grouping. All right, welcome to big time mathematics, guys, because now we got to figure out how to factor this without being able to group it. Okay, so here is the process we're going to follow. We're going to be doing some guessing. Guessing can take a very long time unless we narrow down our possibilities. What are our possible guesses? Our possible guesses are called the possible rational roots. From now on, I'll refer to them as PRRs.
Wait.
Possible rational roots. Okay, these are what we call the PRRs. To find the PRRs, you take factors of the constant, and the constant is the last number. This is the constant. And you divide that by the factors of the leading coefficient, which is the first number. So in this problem, my leading coefficient is 1. All right?
Will you leave that up for a second?
Yes. Now, what are the factors of 6? Now, first of all, choose one of them. I'm not going to worry about the negative because I always include plus or minus. My factors can be positive or negative. So I'm looking at the number 6. What are all the factors of 6? Jaden said 2. What else? 3. What else?
1 and 6.
1 and 6. So we have 1, 2, 3, and 6. Put them in any order you want, but you got to have those 4 numbers. Plus or minus 1, 2, 3, or 6. When we say factors, what we mean are, these are the numbers that you can divide into 6. Right? Can't divide 5 in, can't divide 4 in. These are the numbers you can divide. Now, what are the factors of 1? Just 1. So basically, because that's just 1, this is a fraction, and since that's just 1, we're looking at 1, -1, 2, -2, 3, -3, 6, -6. Now, I wrote them all out because I want you to see there's 8 of them, but you can use plus or minus. You do not have to write them all out. You can use plus or minus. Now, what this means, kids, is when you go to graph this, and eventually that's our goal, right, to graph it, these numbers right here are the only possible places where dots can go. So there's going to be 3 factors for this problem. How do I know that? Because it's cubed. Right. If it x to the 4th, there'd be 4. And I know that what's going to go in here is coming from this list. So, yep, I have to guess. But it's not as bad as it could be because I know I'm only guessing from those 8 numbers. Okay?
Are those the 8 numbers you're always going to use? Oh, wait, just kidding.
Now, I'm ready to start guessing. So I'm going to have to erase something here because now I need some space. So I'm going to start guessing. So here's what I want you to do. I want you to guess one of these numbers. I don't care which one. Guess one.
1.
1. If 1 is the number that you are guessing, and I can only do 1 at a time. So if 1 is the number that I am guessing, I am going to do what's called synthetic division. You did this last year, I think. I'm going to put my guess in a little box out here. Does that look familiar? A little box out there? No? Okay. Well, pay attention. So I'm putting whatever I'm guessing, and I'm guessing something from this list, I'm putting it out here in this little box. Now, I'm going to write down next to the box here, just like this, I'm going to write down all of the numbers, no letters, but all of the numbers from my problem. Okay? Now, I'm going to draw a line across here, but I'm leaving a space because I'm going to put a number. I'm going to put some numbers in here. So make sure you leave a little bit of space. All right, so here's my guess in the box. Here are all the numbers in the problem.
You bring the 1 down.
And I bring this 1 straight down. So force yourself, draw an arrow, straight down comes that 1. Or this number, whatever it is, comes straight down. Now we take 1 times 1. Jay remembers, you guys did this. We take 1 times 1 and put it here.
What is this? And then 2 minus 5.
1 times 1, put it here. Now add, so that gives me 3.
That's why.
1 times 3, put it here. Add. 1 times -2, put it here. Add. Okay, so again, these were the numbers from the problem. I dropped the first number straight down. Then I multiply, put the answer here, add. Multiply, put the answer here, add. Multiply, put the answer here, add. Now, you didn't guess right. Because if you guess right, this will turn out right here to be a 0. You want this to be 0. Because what you just did was a division problem. You just did a division problem, and this guy is the remainder. You know how when you divide, sometimes you get a remainder? Well, we got a remainder of -8. And if you're a factor, you don't have a remainder. You divide in evenly. 5 is a factor of 15 because it divides in evenly. Okay? So we guessed wrong. So then somebody else said, let's guess 2. Okay, let's guess 2. So now I'm going to repeat the process, but I'm going to guess 2. This is for, this is a lot of work. Welcome to the fast lane, folks. Yeah. Yeah. So here we go. We're going to repeat the process. So I'm dropping my 1 straight down. Here we go. 2 times 1 is 2. Add is 4. 2 times 4 is 8. Add is 3. 2 times 3 is 6.
Let's go.
Right there's the 0 that we wanted. Remember? You are trying to do the synthetic division process and end up with a 0. You just found 1. 2 is a 0. Okay? So remember when we said we were going to build 3 factors? Right? Because we want to put dots on our number line. The number that you guessed is the dot on the number line. So you now know you have a 2 on the number line.
How much work space do we have?
Which means that you have a factor of x minus 2. Because that's what would give you the dot of 2. Right?
Now we gotta do it 2 more times?
Now, here's the good news. Jaden is saying, oh my gosh, I have to do this 2 more times? No. Here's the beautiful part.
I guess if 1 is x negative.
When we did the division, this was the remainder, came out 0. But this right here is x squared plus 4x plus 3. Remember how when I originally wrote down these numbers, I left the letters out? But this was really x cubed and x squared and x, right?
Mm-hmm.
Well, when I did the division, the power comes down by 1, because I'm making it smaller when I divide something out. So now this first number isn't x cubed anymore, now it is x squared, and then down to x, and then my plain number. That, kids, you don't need to guess and all that. That you can just factor, can't you? How does this factor? Just factor it like a regular Algebra 1 problem. X plus 1 minus 1? No.
Plus 3.
Plus 3 plus 1?
Yeah.
So those are your other two factors. You don't have to guess, you're just going to factor them, which means that the dots are going to go where?
Plus
At -3 and -1? Now look back at your problem. It's just a regular old x cubed, right? So it's going to start down here, and there you go. Awesome, awesome work.
break time.
No, no.
I have no idea what's going on.
Okay, well that's good, because we're going to do another one. We're going to go through the process again.
I didn't even know how to do it before we
Yeah.
started.
Wait, but why are you, if it's still cute, why are we still knowing to go straight through, just like, oh, because it's not counted?
Any of these have powers? Nope. Yep, so it's all there for you. All right, here we go. Next problem, I'm now on page 18. And my next problem
Wait,
is x cubed minus 6x squared plus 11x minus 6. All right, here we go. Now the first thing that we should look at is, can I group it? Because grouping is way easier than what we just did. So can you group this?
No.
We can take an x squared out of here, but look at that. Is there anything we can take out of there? Nothing but a 1, and that would not give me the same parentheses. So here's another problem that does not factor by grouping. So we're going to do exactly what we just did. So pay close attention. Mary Kate, what are you doing? Huh? Okay, that's why we don't know what's going on. Put the phone away. No, I want it in your backpack, turned off, so it doesn't tempt you. All right, so here we go. What are my possible rational roots? If grouping doesn't work, I am going to have to guess. So this is my list of numbers that I'm going to guess. All right, so here we go. Factors of 6. Oh, this is what we did last time. So it's going to be plus or minus. I'll put them in order. They can go in any order, it doesn't matter. But 6, 3, 2, and 1.
Why you just switch them?
What do you mean switch them?
Why you switch?
I don't understand what you mean by switch them.
You had the one in front for.
Okay, the order that you list the numbers doesn't matter. This is simply a list. So you can put them in whatever order you want.
Are you screwed?
But I do have to remember that it's over factors of the leading coefficient, but just like last time, that is 1 again. So all my numbers are exactly the same list as I had before. Okay? So now it's time to guess. Now you know what your pool of numbers is. Positive and negative, 6, 3, 2, and 1. Alright, so what do you wanna guess this time?
Three.
Three.
No. No.
Negative.
You are allowed to guess whatever you want,
Negative 3.
but I'm guessing 3 because that was the first number that was thrown out. It doesn't matter. Pick a number out of the list and guess. Your guess goes in the box. And then notice I wrote down 1, -6, 11, -6, right? Make sure you write down all of the numbers in the problem. Draw a line across. And then drop this number straight
It
down.
works, let's go.
Jaden says it works. Well, let's see if we can figure it out. So 3 times 1, write the answer here, and add. 3 times -3, write the answer here, add. 3 times 2, whoop, write the answer there, and sure enough, we got a 0. Yep, we're smiling because we're happy. We do not have to guess anymore.
Where's the negative 9?
3 times -3. Now, that means what in terms of my picture?
There's a dot.
There's a dot at 3.
3 minus 1.
So I know there is a dot at 3. Okay?
And then it would be 1x squared
Now,
minus 3.
what's left
X squared.
X
is
squared.
x squared minus 3x plus 2. Remember, this is always 1 less power than you started with. So if you started with x cubed, then the answer is going to be x squared.
Oh, it's negative.
Then, hopefully, you can just factor that.
X minus 1, x minus 2.
X minus 1, x minus 2 is how that factors. By the way, if you can't get it factored, you can always use the quadratic formula, right? But every one I give you will factor, so you can factor it.
X minus 1 and X minus 2, the other points.
So those are gonna give me the other 2 points. So I have a point at 1 and oh gosh, they're all right in a row here. Right?
Yeah. And then there's no like square, so it's just up and down straight through, right? You start up and down.
Yep, there's no negative out in front of it. So I'm gonna start down here. And then I'll just go through, and there we go.
Now it's
Why?
break off.
Okay, so there's a lot to that problem. Luckily, there's another one. Good deal. All right. So let's make sure. Any question about this before I erase it? All right. So here we go. Let's do the next one. We're going to pay real close attention, and maybe some of the missing pieces will get filled in.
Wait a minute, we can group this one.
Oh, Jaden says we can group this one.
I don't think it matches though.
Yeah.
Okay, so let's talk about that for a second. First of all, Jaden made the observation, well, I think I can group this. And then he noticed something, because if we group it, and we take out an x squared, we get x plus 4. Now here, I can take out a -3, and now I'll be left with x plus 6. Now, Jaden was correct when he said, oh, you can group it. But then he said, wait a minute, they don't match. And he's right. So this doesn't work. Yes, you can physically do a grouping, but you can't factor it that way because your parentheses don't match. Does everybody see that? Now, again, I'm proud of Jaden for noticing that maybe it grouped, because grouping is always easier than all this guessing and all of that. So if it groups, that's how you want to do it. But this one doesn't group, so we're going to have to do our guessing. Clara?
Well, like if we were on a test, would it like say the factor and sketch part, or would we just always have to check grouping first?
You're on your own. Yep. Yep. So here we go. I know it doesn't factor by grouping, so I'm going to have to do my guessing.
That's 18.
And so I'm going to do my PRRs. So I want the factors of 18. Remember, always include plus or minus. Jameson, always include the plus or minus. So 18,
2, 9.
8, okay, I'm going to do it this way. He said 18 and 1,
2, 9.
9 and 2,
6, 3.
6 and 3. Is that my list?
Over 1.
Antoine, you need to, first of all, you need to open your mind, quit trying to be cute or argumentative, and simply write down every number that will divide evenly into 18. The order that you write it down is irrelevant. And the way that makes sense to me, the way that makes sense to Jaden may not make sense to you, and that's okay. But you gotta figure out a way to come up with the factors of 18, right? And I think you can do that. Write them in any order you want, plus or minus, okay? Thank you. Now, don't forget though, that this has to be over the factors of the leading coefficient. Now, it's possible, we've seen them before, that we could have a number out here in front, right? And if we did, let's say it was a 2. Then down here we wouldn't have just 1, we would also have 2. What does that change? Well, that means that then all of a sudden you would have fractional possibilities. Because if there were a 2 down here, there isn't. But if there were, 3 over 2 would be a guess, a possible guess.
How would there be a 2?
If the number out here were 2.
Do those count together?
Alright, but it's not, so let's not worry about that till we hit one that has that. Alright, so there are my possibilities.
It's not 6.
6.
It's not 6. It's not
Okay,
6.
so she already guessed 6
It's 9, right?
and said it doesn't work.
It's 9.
It's 9, alright, let's try 9. So I'm gonna try 9.
Are you guys
9,
figuring it out so quickly?
9 is a number,
They're just guessing.
9 is a number in the list.
They're literally.
Please, do not guess a number that isn't in the list. If it's not in the list, it will not work. Alright, so 9, alright, then here are my numbers, 1, 4, -3, -18. So make sure when you copy down your numbers, you're including the negatives.
So you do 1 time 1.
Alright, so here we go.
One drop.
So 9 times 1 is 9, that's 13. Oh my, this is gonna get really big.
This
It's
isn't
2.
it?
It's 2. I just did it.
Guys, can you see that 9 isn't gonna work? Because 9 times 13 is gonna be a great big number.
Let's do 3.
It's 2.
So it's 2.
I didn't know it was 2 on there.
Alright, let's try 2. Drop your 1 down, here we go. So 2 times 1 is 2. Add gives me 6. 2 times 6 is 12. Add gives me 9. 2 times 9 is 18. And adding cancels out. Okay? So that tells me, remember, my job is to graph. I'm supposed to be graphing this thing. So that tells me that I have a dot at 2. This is where the dot goes. Whatever guess worked, that's where you put the dot. Now, what's left? X squared plus 6x plus 9?
Wait, I got a question. If you get x plus 3 and x plus 3, is that squared?
Oh, wait a second. Is that factors? Is x plus 3, x plus 3?
Yeah.
Yeah, so is it squared?
So that means, let's look at the whole problem. We have an x minus 2, that's this one. That's the one we guessed. But then we have x plus plus 3 squared. Two of them that are exactly the same.
So is it gonna hit now?
So that means I'm gonna have a dot at -3, right? -3. It's gonna start down here, but you're exactly right. When it hits that dot, it's gonna bounce off, come back around, and go straight through.
Wait, where did you get the two, the x minus 2, x plus 3?
Okay, these were the factors that were left over after I did the division. So that's x plus 3 squared.
Okay.
I already knew one of my dots was at 2, that's the factor x minus 2.
How did you know that it was already at 2?
Because that's the number I guessed and got 0.
Okay.
Whatever guess works is your first dot on the picture. And there's a factor associated with that dot.
So how do you know, after you do like solve, how do you know, like, how do you get the x plus 3, the 2x plus 3, how do you?
That's this factor.
Okay.
I factor that.
You use one of those to put them on the graph, and then you use the number you need to,
Right,
yeah.
right. Right.
So even if it says, sorry.
Yep, we got one more.
So even if it says ER, you should always check to see if it can factor.
Yeah, yeah. These aren't gonna factor, but like just a random problem on a test or something, you should check.
Why is it 2 negative?
Because the 2, when I divided it in, gave me a 0. And the number that gives me a 0 is where I put the dot.
Say that again.
Wherever the number is in the box, that's where the dot goes.
Okay.
Okay? Alright. Okay, we're gonna try one more. And we'll be done then. So we'll take a break, Jaden, after we finish this problem.
Forever?
No. Till tomorrow. Alright, this one actually is gonna be a little bit easier
There's only 2 factors.
because there's only a couple of PRRs. Right? Because your PRRs are factors of 7, which are just 7 and 1 over 1 again. So you only have 4 possibilities. 1, -1, 7, -7. So what do you want to try? 7? So 1, -9, 15, -7. Please be careful when you copy these numbers down and make sure you're including the negatives.
It's actually
Here we go, I'm doing 7 because that's what we started with. So this gives me -2. -14 gives me, oh no, that works.
Ooh.
Doesn't it?
Finger.
I think 7 works.
Finger.
I got
Negative
I
7
just
and
messed
negative
up on
7.
Same.
Negative mama is 7 is negative 2.
Okay, 7 times 1 is 7. -8 plus 7 is -2. 7 times -2 is -14. 15 minus 14 is 1. 7 times 1 is 7. Added up gives me a 0. Yep.
You can tell us something about a graph.
That's fair.
So that means that I am gonna have a dot at 7. Because as soon as I can divide in a number and get 0, I'm gonna put a dot there.
You may stop doing that.
Now, that also means that I have a factor of x minus 7. Because that factor would put a dot at 7. Now, what are my other factors? Well, what's this? X squared minus 2x plus 1. So that needs to factor into something. What does that factor into? X minus 1
X minus one.
X minus 1, X minus 1.
Cause you do 1 minus 1 equals negative
So
2,
it's
and then
squared.
1 times is negative 1.
Yes, it's a square.
Square, now it's off.
So, again, guys, this is first year algebra factoring. Watch Khan Academy, Google it, something, practice on your own. We don't have time to go back through that. If you FOIL this out, it gives you this. Okay, that is factor. Now,
Start down. This is two.
Twan noticed that there's 2 of those, right?
So you start.
We know, oh wait, so I gotta put a dot here, there's a dot at 1. We know it's a regular cubed equation, so it's gonna start down here. But when it hits that first dot, that's a squared, so it's gonna bounce off and go through the second dot.
It would go up and come back down.
Yep. And there you go. Now, wait. We got time to do one more. I know, but we're gonna do one more. You can focus. I know you can focus. All right, here we go. Guys, well, actually, we don't have a whole nother problem. This is just synthetic division practice.
It's 2 goes in the box.
Now, there's something tricky about this problem though. First of all, Jaden has observed you put a 2 in the box.
Why is that?
Now,
Why is that?
okay, now just stop and think for a minute. Before you speak, think. I just erased it, but when we did this problem, we had a 7 in our box. That put a dot at 7, and it made your factor x minus 7. So if the factor is x minus 7, the dot goes at 7, and that's the number that goes in the box, right? So since the factor is x minus 2, that means there would be a 2 dot, and there would be a 2 in the box. The dot and the box are the same. Okay? Now, here's what's tricky about this one. You gotta put a 0 in. Because if you look carefully at your problem, what is missing?
X cubed.
The x cubed term is missing. And when you do synthetic division, it has to go down in order. We did not run into that with any of our other examples, but it's a rule. It has to go down in order.
Where'd you get the 0 from?
It has to go in for x cubed. That's a
Look at your
placeholder.
problem. There is no x cubed. It goes straight from x to the 4th to x squared. You have to put the missing powers in. There is no x cubed. Everything has to be there. If it's missing, you put in a 0.
So if that's the case, are we going to look up on 0? That's going to make everything look today?
No.
Or 2? Oh,
No, think about it now. So first of all, here are my numbers, right? Now bring the 2 straight down. Always the first number comes straight down. 2 times 2 is 4. So that isn't going to be a 0, Jameson. That's going to be a 4. And then 2 times 4 is 8. So that's 11. 2 times 11 is 22. So 13, 26, 27. Now wait, we're going to finish this. Obviously, this is not a factor because I did not get 0. But I'm not graphing. I'm going to write my answer now. So this is my answer right here. Okay? So it's 2x to the 3rd. Why is it to the 3rd? Because it's always 1 less when you divide. And the original was to the 4th. So 2x to the 3rd plus 4x squared, now I'm going to write down, plus 11x plus 13. And what's that?
Remainder.
That's my remainder. So it's 27 over x minus 2. This last number is our remainder. Now, before you start asking, because you guys, you don't put your thinking caps on before you ask. If I divide 5 into 11, I get a remainder, right? Doesn't that represent 1/5, 2 and 1/5? Yes, it does. That's what 11 divided by 5 is 2 and 1/5. Your remainder goes over whatever you divide it by. Okay?
Where'd you get the 5?
Oh, this was made up.
Oh,
This was just another example.
Wait, what do you mean it goes over?
Take your, whatever your remainder is, and put it over whatever you divide it by.
And that's what you think.
This is the answer right here. All we were doing in this problem is dividing. So we don't have a picture, we don't have guesses, we're just doing